Imagine a bank wants to add a new payment time. Engineers expect it to take 2 days, but it actually takes 3 weeks because changing that payment model breaks transaction history, notifications, fraud detection, reporting, maybe more services which are dependent on the payment system. So, if this is the case, changing the payment is breaking all the other services, then is it the problem with code change? No, it is the problem with modularity of that software architecture, of that system, right? How do we evaluate modularity? What is exactly is modularity? Let us understand one by one. Modularity is about breaking the system apart into smaller pieces. Say we have a banking system now, which is a complete one module, right? Which consists of multiple services. They are tied together in one single big module, right? There is payment processing service, there is accounts, there is notifications, generate statement, and fraud detection. Now, this is a single entity. This is single entity. This is a implemented in monolithic architecture. Okay? Architecture pattern, right? We have discussed this in earlier sessions. Now, what is modularity? Modularity is breaking the system into smaller, manageable pieces, right? Now, to explain modularity effectively, we take help of three concepts, right? That is, the first is cohesion. Second is coupling. Three, Connascence. We will see each one of these with example. Right? Now, when we tied all the services together, this is a poor cohesion. What cohesion actually represents? It is single responsibility of each module. Now, instead of tying all these modules together, what all these services together, what we do, we break these into models. Payment processing is going to be model 1. Accounts is going to be module 2. Notifications 3, M4 and M5. Right? Now we have broken the entire payment service, a big model, into multiple smaller models. This is cohesion. Now, these are independent of each other, and changing one may not affect other. Right? We started with the same example. Now, adding a new payment should not affect other services or maybe less changes. Right? This is modularity. Cohesion explains single responsibility of each model. The payment processing is only responsible for handling the payments. Account will have all the information related to the user account. Notifications is dedicatedly used for sending alerts. Generate statement is dedicatedly used to handle statements, right? So this is cohesion, single responsibility of each model. Now, what is coupling? Coupling is what is dependent on what, right? Now, um, say example, um, I have a payment. Now, this payment is after the successful payment, it is sending data to notifications, fraud detection, and statements. So what we see here, there is a tight coupling between payment service and notification service. If, say, the fraud detection is changed, the API used by payment service, now if the fraud detection API is changed, the payment also has to make the change, right? If the statement API changes, payments also has to adopt that change. This is tight coupling. Payment service itself calling all the other three services is tight coupling. What we can do, how can we reduce this dependency? Is now instead of payment service making call to each individual services, what we can do, we can make use of a pub sub model, right? Pub sub. And there is a topic. We have discussed about this in earlier session. Please take a look for more understanding. Right? Pub sub topic. Now, the payment service will just send the data to this topic. Now, the notifications, fraud, fraud detection, and statements all are subscribed to this topic. The payment service job is only to after the successful payment, push the data to this topic. Now, these services are subscribed to this topic. Each one will pick the data whenever it arrives and use it for their own processing. Payment service is completely independent of the usage of data by other services. Now, if there is a change in fraud detection, there is no change in payment service. This is a good example of coupling. This is loose coupling, right? This makes less changes in the system, less dependencies. Right? This is a good coupling. Now, what is connascence? Connascence is when we change one thing, what are the other things dependent on that has to be changed in order for that system to be successfully working. Example, say payment service, payment service sends data something like account number, account number, and maybe 1, 2, 3, 4, 5 and amount. Now, this is the type of data the payment service is producing after the successful payment. This data is being used by all my services, that is accounts, notifications, statements, fraud, right? So all these are also now using the same format data. They are expecting the same format, payment services expecting in the same format. Now, if the payment service changes its data format to, say, ACC number, instead of full account number, it now changes to the variable ACC number. Now, all these services also need to change that to accept the data format, new data format. So now this is a bad example of connascence because it is expecting or demanding changes in all the places. So now our goal is to reduce the dependency, right? So a good architecture explains modularity in these terms. More, more cohesive, less coupled, and low connascence. So this is a example of good modularity. Modularity is one of the most important concepts in software architecture because ultimately software systems spend far more time being changed than being built, right? The easier the system is to change, the more valuable the architecture becomes over time. It should always be loosely coupled and easy to adapt new changes because the software built now should be foolproof for future as well. Maybe 5 to 10, 15 years from now. It is not that today it is fulfilling all the criteria and we are done for the job. It should be able to adapt to new changes. That is the whole point of a good software architecture. Thank you for your valuable time. In the next sessions, we will continue exploring more software architectural topics. This session is part of software architecture series. There are more concepts covered on all the other topics of software architecture. Please take a look. Thank you.